Welcome everyone to the latest installment of the Intel Network Builders webinar program. Thank you for taking the time to join us today for our presentation titled Exploring the Full Potential of an NFV-enabled SD-WAN Solution Delivered by Intel. Before we get started, I just want to point out a couple of the features of the BrightTalk tool that may improve your experience. There is a questions tab on the bottom of your viewer. I encourage the live audience to please ask questions at any time. Our presenters will hold answering them until after the presentation. Below your viewing screen, you will also find an attachments tab with additional documents and reference material, including a number of websites and documents mentioned during the presentations. Also, at the end of the presentation, please take some time to provide feedback using the ratings tab. We truly value your thoughts, and this information will help us improve our future webinars. The Network Builders webinar program takes place every week, so please check back to the channel to see what is upcoming and access our growing library of recorded content. In addition to these resources, here you will also find a comprehensive NFV and SDN training program through the Intel Network Builders University, which is located on the website. So today we are joined by Happiest Minds, who are our presenters, and with that I'm going to hand it over to them.
Thank you so much, Lindsay. Ladies and gentlemen, good morning and welcome to the Intel Network Builder channel on BrightTalk. We are Happiest Minds, and today's webinar is about building an NFV-enabled SD-WAN solution that maximizes all of its inherent potential. I'm sure it's a beautiful morning there in the US, and we're sort of burning the midnight oil here in India, as we wanted to ensure that we were accounting for our friends who might be dialing in from the West Coast. While we wait for people who might still be dialing in, I would just like to take a couple of minutes to introduce Happiest Minds and who we are as an organization. You can go through all of the highlights on the slide, but essentially we're a young, nimble, and quickly growing company that is focused on providing transformative business solutions to enterprises and technology providers by integrating a set of disruptive technologies like big data, IoT, analytics, cloud, and of course, software-defined networking. In case you were wondering, Happiest Minds isn't a very typical name for an IT services company. You're absolutely right. We have happiness at the core of everything, as we believe happy employees lead to happy customers, and we embrace mindfulness as the core of everything that we do. If you find that to be an interesting concept, I would encourage you to check out that on our website when you have some downtime. Today we will be showcasing to you how you can use open technology approaches like the ones provided by Intel and leverage the expertise of a partner like Happiest Minds to maximize the potential of an SD-WAN solution. So without any further ado, let's get acquainted with the people who will be presenting the story to you over the next 40 minutes or so. We have Dharamraj Chatakia, who is the General Manager and Head of Software-Defined Networking at Happiest Minds. Dharam is an industry veteran with more than 16 years of hands-on experience in software engineering for networking products and solutions for both Fortune 500 companies as well as rapidly growing startups. Riding in the sidecar with him today is Purnendu Ghosh, who's an architect with the Data Center Technology Group and actively works on some of our most important projects on a day-to-day basis. And finally, my name is Arsalan Kashraf, and I'm the Director of Marketing for PES at Happiest Minds, and I will be serving as the moderator for today's session. So as most of you who are watching this webinar live would be with SD-WAN, we didn't really want to start off with the basics. Instead, I put myself in all of your shoes and decided to jot down a few questions which will serve as the anchor to our discussion today. So with that being said, let's jump right into it. Dharam, I'll start with you. SD-WAN is a fairly novel concept, and we know that it's been around for a couple of years and it has tremendous commercial upside. Can you walk us through why SD-WAN has gained prominence and what are some of the trends that are disrupting traditional wide area networks?
Sure, Arsalan. Thanks for the introduction, though I don't agree with you that I'm a veteran. I'm still a learner in this industry and way away from retiring. So there are quite a few trends which are disrupting the traditional WAN as we know, right? The first and the most important one is the revolution that is happening in the enterprise infrastructure. So as all of us would be aware, applications are getting distributed across private, public, or hybrid clouds and offered as a service. There are dynamic scaling requirements, so mergers and acquisition, addition of branches, global workforce, etc., etc. And then the third wave, of course, is on the BYOD, right? For every one device that an enterprise gives to its employees, there are 4 others that then the employee brings himself with him. So that all of these require a very dynamic network infrastructure. The second important trend is the growth in high bandwidth applications. So video conferencing, VDI, and video-based content consumption, like online learning and stuff like that. The third important point is on security. So you have a lot of point of sales and online payment transactions, secure transactions that are happening across the branches and the HQs. The BYOD phenomenon itself poses additional security challenges which need to be addressed. And the third point within the security paradigm is of the constant threats and hence a constant need to configure and reconfigure security policies dynamically through a learning IPS system. The other important aspect is the number of connectivity options that are available today. So you have redundant fiber links that can be made available, and at the same time a very high bandwidth 4G or 5G wireless link, which are extremely critical for remote sites where the traditional connectivity options like fiber may not be possible for the access. So these in nutshell are a few important trends which are disrupting WAN and making for the need of an SD-WAN.
Thanks, Dharam. That was certainly a very comprehensive introduction. Let's go over now to our resident architect and check with Purnendu about what goes into the making of an SD-WAN architecture and what are some of the advantages that it has to offer.
Thanks, Arslan. So, from an architecture point of view, we at Happiest Minds, look towards the future of WAN as a managed service offering, which would ideally be integrated with SD-WAN and NFV. And before I go to this, this very specific outline of our presentation, I'd like to talk a bit about the current SD-WAN deployments that has 2 distinct characteristics. So at first, there's you have this introduction of the central hosted, a platform, which ideally could be an, on-premise or cloud, which would ideally consist of, the SDN controllers, talking to the edge devices, and various other functions which, would ideally reduce the footprint, or, it also reduces the management complexity of maintaining all of the physical appliances which are currently deployed in the traditional WAN. Now these, so devices could be an antivirus or a firewall, or basically so IPS. Now the next characteristic is the traffic steering. So this, so the traffic steering capability of the SD-WAN enabled edge devices, among the outgoing links, which is ideally based on the policies that are pushed from the controllers as the flow rules. This creates an opportunity to optimize the WAN, for enhanced application performance and also increasing the quality of experience. Now, so far so good. However, there is an evolution that's happening at the service provider infrastructure side as they move towards the virtualized infrastructure, to build and scale their entire managed service network service for their customers. Now when that happens, we are going to see SD-WAN being delivered as a managed service to the enterprise customer, and this is the central theme of our webinar today. Now coming back to the architecture, you would see 3 major components. On the left hand side is the centrally managed edge devices, which I just explained, and on the right hand side you have the NFV component consisting of the virtualized infrastructure, which ideally would be running on COTS hardware, and which has the VNF and the NFV orchestrator, which basically manages and basically configures the VNF to introduce new services. And the third component in the top is the overall overlay network, which ideally would be managed by a centralized WAN orchestrator, which interfaces both with the SD-WAN controller as well as the NFV orchestrator. Now, answering the second question from Arsalan, I'd like to list some of the key advantages of this architecture. So first, for a SD-WAN, managed services, offering, the first advantage is basically the multi-tenancy. So you can offer a single instance of the orchestrator and basically manage multiple business customers. Second is basically the network slicing. Now, this has two applications. First, you can split, multiple controllers over a geographical area, and then you can have local policies which you can apply. And the second is basically a prominent use case of 5G, where you can split the network resources and allocate them based on the application priority. The other advantages are basically bandwidth optimization and the increase in the quality of service or the quality of experience. Additionally, you have the controller, so you can add policies to enhance the security and the policy control mechanism that you have. And at the last, it is very, very easy with an with an SD-WAN managed services with NFV if you want to deploy a new customer office or so basically a POP. So if you see the overall advantage here, we see the solution as introducing a lot of new services for a telco provider. That would ideally mean an increase in revenue streams, which is apart from the obvious reduction in OPEX and CAPEX. So basically net-net, I feel this is a very winning solution for both the enterprises and the service provider.
Great. So, Dharan, let me bring it back to you. While talking about the SD-WAN architecture, Purnendu mentioned edge devices, cloud infrastructure, and services. So let's actually get into all of these one by one. Can you spend perhaps a couple of minutes to talk a little more about edge equipments and the role they're expected to play in an SD-WAN architecture?
Sure. So all of these components are quite critical, but then the edge equipment is also very critical because that is going to be deployed at the customer site. So there are a few properties which an edge equipment needs to have while making a selection or choice. The first one being that it should be based on COTS hardware. That gives maximum benefit respect to the CAPEX and OPEX. Other important property is that it should be SDN enabled. So that gives you two benefits. Number one, it can be plug and play. So you just connect the edge device to the internet and it would be able to kind of download the software and self-provision it. This saves a lot in terms of truck rolls and the expenditure involved as well as the time to bring it up. The second benefit that you get by having it SDN enabled is that you do not need any proprietary management software. SDN applications using SDN controller can manage the device and give maximum you can say programmability and flexibility. The third point is again tying back to what we discussed on the availability of multiple connectivity options. So the device should have multiple interfaces, like it should support fiber as well as wireless technologies like LTE. This allows redundancy, so in case say there is a cable cut and those kind of failures, then the traffic can be steered on a wireless link. Also it can allow the sharing of load between these link options. Programmability is one of the other key features for the edge equipment because that allows the service provider to deploy new services without making any change in the hardware, right? So like there could be firewall bypass or deep packet inspection and these kind of services which can be dynamically deployed if the edge equipment is also this allows you to have things like over-the-air update, which will prevent again a truckload of replacing the equipment or a need of a technician to visit and do a software upgrade if the over-the-air upgrade of the software is supported. So when you look at all the features, right, there are quite a few options, and what we have found is that, for small branches, Intel Atom-based CPEs with DPDK, for example, can help you give all of these features that we talked about. And for larger branches, we can possibly choose either a white box switch or a compute node on which a CPE can be deployed as a VNF.
Thanks, Dharam. So we'll move back to Purnendu now to actually inquire a little more about an NFV infrastructure. It seems to me that this would be the solid foundation upon which you build a robust SD-WAN solution. So Purnendu, can you elaborate a little more about the role that NFV-based provider infrastructures can play in an SD-WAN architecture?
Yeah. So, thanks, Aslan. So, if you see the overall, so the provider cloud infrastructure outlined in architecture diagram, it basically follows the NFV. And going by this in a specification, we can see three distinct components. So at the bottom, you would have seen the NFV infrastructure, which is basically an abstraction, over the physical storage, compute, or so the networking infrastructure. Now these components are not similar from the large number of physical appliances currently deployed, and they are now based on Intel-based, microserver architecture with very less footprint, and also allowing the infrastructure to scale based on the demand for the resources by the VNF or the virtual network functions. The second component at the middle are basically the virtual network functions. These are the virtualized counterpart like a vFirewall or a vLoad balancer or a vSBC, which are currently existing as the physical appliances. Now all of these functions are managed by a VNF manager, which is basically responsible for creating or configuring and most importantly chaining the instances of these functions to provide a service as orchestrated by the MANO layer, which is basically the third component. Now MANO is a very specific HC term, and it stands for management and orchestration, and it is responsible for the resource and the service orchestration. It is entirely responsible for managing the life cycle of the VNF that we just explained, and it has very standardized interfaces to the VNF manager and the NFV infrastructure. In addition, if we follow the HC, they have also outlined standard interfaces to the traditional OSS and the BSS systems.
So essentially, we've ticked the first two off of our list. So far, we've talked about edge devices and also about the NFV infrastructure. But using all of these, Dharam, what are some of the services that can be offered to the end users by service providers and by enterprise IT teams?
Sure. So if we were to list down all the services that one could think of, it could take days, looking at the current and the possibility of the future services. But I would like to highlight a few ones which are quite important. The first one is the ability to create dynamic tunnels. Now this is very important when you are having a high bandwidth application like a video conference between two users across two branches. In a traditional WAN architecture, typically the traffic would go from one branch to the hub to the branch, and hence it becomes a hub and spoke kind of an arrangement. Whereas in case of SD-WAN, it is possible to create dynamic tunnels between two branches, and then the traffic can be exchanged between the two branches without going through the hub. So that can improve the experience of the video conference with respect to the quality. The other service that can be deployed is on with respect to selective encryption. So not all flows or applications will require encryption, and hence it is you can select the flows towards important transactions like a point of sale or payment gateways, which can be encrypted, whereas other non-critical flows need not be encrypted and thus reduce the latency. The other service that can be offered is an application-based optimization. So you can have application-aware policy management, and traffic steering for better application performance. Other important point, and what it is getting a lot of traction now, is with respect to the monitoring analytics. So how you can monitor your network and then use the intelligence using analytics to kind of complete the feedback loop and offer services. So you can optimize the traffic distribution, you can reapply policies or create new policies on the fly. For example, if there is any network anomaly detected, then you can quickly reconfigure a new security policy and prevent any further damage to the network. You can anticipate network or service disruptions before they happen, right? And help in creating more advanced functionalities like business forecast and stuff like that based on the way the network is being confused. So all of these can kind of help you to give more value and hence more ARPU or average revenue per user.
That's definitely good information to have from a technical standpoint. But I was wondering from a business perspective, what do you think are some of the drivers for providers to offer SDN services?
Right. So tying this back to some of the services that can be that can be offered and that we discussed, right? It creates new revenue streams. Like for example, it is possible by offering the network functions as a service and low-cost edge equipments to have small and medium enterprises as your customers who were earlier would not have been able to subscribe to WAN services because of the prohibitive cost. The second thing is that you can also increase the revenues by offering connectivity to remote locations, which was not possible because of the operational challenges of truck rolls and last mile connectivity, etc. That we discussed. So you can have new customers and you can have more branches from the existing customers, creating new revenue streams. The second point is with respect to the advanced services, which help you in delivering more value to the customers and thus increase the ROI from existing customers. Point in case being advanced quality of service, advanced analytics, advanced security, and whatnot. Now, apart from the revenue, cost also plays an important role when service provider looks at its own profitability criteria. And by adopting an standard open hardware architecture and software architecture based solution, one can have a substantial reduction in capex and opex, and also have the ability to kind of scale up and down based on the load. So I guess for me, these are the three key drivers which would persuade service providers to offer SD-WAN as a service.
So gents, all of this seems to be great on paper, but like they say, the proof is when the rubber meets the road. So at this point, can you talk to us about how telecom service providers like, let's say, AT&T, CenturyLink, Bell, Verizon, or even enterprises like Kraft Foods, General Motors, or Ford can benefit from an SD-WAN solution? And also, can you provide us with some anecdotal information about the work that Happiest Minds has done using open technologies offered by companies like Intel?
So, Arsalan, it's a good question, and so there are two aspects to it, right? One is what are the kind of services that a company like Happiest Minds can give to the service providers or the OEMs who are either building the SD-WAN solution or are looking at deploying the SD-WAN solution. So Happiest Minds has expertise in SDN, NFV, and the classical networking, a strong foundation on classical networking, and we provide services right from system design to software development, testing, analytics, and DevOps. So Happiest Minds can be a partner who can work with service providers to kind of create a heterogeneous solution combining proprietary and open source technologies, and be a single point of contact for designing, developing, deploying, and providing necessary support. So with that, I would request Punendu to walk through on our experience building a NFV-based SD-WAN using Intel technologies.
Thanks, Ram. So we so basically built a solution which is an service provider controlled SD-WAN centric NFV cloud infrastructure, and we had developed this Intel powered solution for one of our leading equipment vendor. And here the vendor wanted to position their infrastructure as a compact cloud solution which would be capable of offering SD-WAN as a managed services for their end customers. Now, so let me break down the three components which are very similar to the architecture we just discussed in the beginning of the session. So, on the right-hand side, you have the NFV component, which is powered by Intel Xeon-based physical server, accelerated by Intel DPDK and QAC technologies. And so this is in addition to the pattern matching, which we are currently working to provide a basic and faster DPI on the Intel Altera FPGA. This NFVI is OpenStack Newton running on Ubuntu with OpenStack Tacker surfing the role of VNFM and the basic Nano. The VNF components were basically vRouter, vFirewall, and the vLoad balancer from the prominent ISVs. On the left-hand side, we have the edge devices which were powered with low-cost Intel Atom processor codenamed Wrangly. So Dharam just talked about the advantages of the low-cost devices which you can use at the edge devices. The Linux is accelerated by Intel DPDK and QAT and runs basic DHCP and DNS clients apart from the basic routing logic. Now these edge and the NFV components are managed by a centralized SDN controller whose northbound interface is left actually open, and it is intentionally left open for the service provider or the enterprise orchestrator so that it can be programmed appropriately. And as a part of the job, we also demonstrated an internet access from the edge devices via firewall and the vLoad balancer. So the solution as we see is basically powered by Intel Open Technologies, which is additionally complemented by the fact that we are backed by Intel investments. And at Happiest Minds, we are closely following ETSI, and the specifications are a great knowledge base with large number of use cases using NFV. And I can very strongly conclude by mentioning that with the current experience that our engineers have showcased in designing this SDN and NFV solutions, it basically uniquely positions us to basically deliver many more use cases in the future. So I would like to move over to Arsalan now and take a couple of questions if there are.
Okay, thanks, Punendu. So to all of you listening in, that was our presentation, and at this point of time, we would like to throw the floor open and see what questions we might have. So, Rene, if you have the questions with us, we would be more than happy to take them.
Yeah, I think that's the first question.
Okay. For the SD-WAN solution, what would be key testing areas?
Okay. So, for an SD-WAN, the key testing areas, ideally would be the NFV infrastructure and, the performance of the various, virtual network functions, that we have on the, so this is one of the areas. Additionally, you have the edge devices, so, how well the encryption and the decryption works. This is one area which you can test. You have the SDN controllers, so now, the SDN controllers, have direct connection to the edge devices and, the other infrastructure components. So, so we could ideally test the security part of it. So, I think the edge devices, the controller, and, the performance of the various, virtual network functions that are there in the NFV infrastructure are some of the important, the areas where we can apply testing.
Thank you. What are the key impediments that you see for enterprise IT/operators to adopt open solutions-based SD-WAN?
Well, see the key impediments, if you see, it is basically the technology, currently, the key, knowledge base that you require to go and do some operations on the networks are basically, some of the networking knowledge, which is, offered by CCNA and something like that. But when it comes to SD-WAN, you should have more, knowledge about the business services and how they are basically configured. So, these are some of the, the things which, the enterprise should ideally, know. In addition to that, I would request, Dharam to add some of the points if he has.
Right. So when we engage with some of our prospects who are like service providers or large enterprises, the key challenge that they see is basically like, how to bring the open source solutions together, right? Who will basically provide them and their team the expertise and the guidance on making it work. And then if something fails, who would be the responsible person? So I think that is where, like, they see value in engaging with a product engineering services company like Happiest Minds, because as part of our ecosystem, both with the product companies on their products and software, as well as with open community, we can help stitch these solutions together and then define the complete solution, deploy it, manage it, provide the necessary support, and make them a happy user of the solution.
How do you handle the dual OpEx scenario, managing both legacy and NFV networks?
Yeah. So, if you talk about the OpEx scenario, we saw the architecture, right? And I would just go back to the case study that we took. So here, you have the NFV infrastructure. So the NFV infrastructure, as as defined by HC, has interfaces to traditional interfaces. So these traditional interfaces are basically OSS, BSS. In addition to that, the NFV can also have interfaces to the legacy switches, and the devices. If at all, so they are not, SD-WAN, enabled there, so we can have southbound interfaces, developed at the controller or the orchestrator, to access those devices.
Right. And to add to what Punendu said, right, I mean, of course, there are, like, the legacy protocols for configuring and managing the device, like SNMP, NetConf, etc., which can be used as interface for achieving at least, a partial programmability, if not full. The other aspect also is that the entire SDN and NFV can be overlaid on a legacy infrastructure using certain technology components, actually. So it is possible to work in a dual mode, and studies from Gartner have said that, over a 3-year period, you can bring down the cost. If you are having a 250 branch WAN, then you can bring down the total capex and opex cost from about 1.3 million to say around 450K. So these are, based on research that Gartner has done, actually.
Thank you. We have one more question, and it has multiple components to it. From a service provider perspective, what would be the major differentiated services that can be launched as an additional revenue stream if the SP vents for NFCI? What would Intel-enabled solution support this new revenue stream service? Apart from CapEx savings, what else is in the savings from Intel-enabled solutions?
Okay, yeah, so this question has basically 3 parts, so let me explain the first one first. So, the question is, from a service provider perspective, what would be the major new differentiated services? Well, if you see the NFV infrastructure, you have the various virtual network functions. So when the operator is basically providing SD-WAN as a managed services, he can, opt in or opt out for some of the services. For example, you have the firewall, so he can, basically opt in for firewall, and he can opt in for other VNS, like, basically a deep packet inspection, or, basically a load balancer. So by opting in and opting out, these kinds of services, he can generate, basically differentiated services, which will, add to, additional revenue streams. Now, how would Intel-enabled solutions support this new revenue stream or service? Well, we already talked about the microserver architecture that we have. So with the microserver architecture, it is possible to scale as you need new so VNFs, or if there are additional resources required by the existing VNF, so you could really optimize the OpEx that you spend there. On the edge devices part, with Intel, you have option to have a very thin CP, wherein you basically have a DHCP and basically a DNS, as we have shown in our SD-WAN case study. Or you could also have an antivirus and maybe deep packet inspection on the edge. So by basically combining these the open Intel solutions, you can generate new revenue and so new revenue stream and services. Third part of the question is, apart from CapEx saving, what else is the savings from Intel-enabled solution? Well, the answer is not only with Intel-enabled solution. If you have a SDN overlay network which is offering SD-WAN services, you have the complete a single pane of glass to manage the all the nodes in the network. So that would ideally mean that you will to spend less on managing the network, or basically upgrading, or basically enhancing the network. I would think I would ask Dharam to add some of the points on this topic.
Right. So apart from the direct capex and opex saving, there are other indirect benefits by using proven technologies from Intel and combining services from companies like us. So the thing is that the time to market or time to build the solution reduces drastically. So you have things like DPDK framework, where there are certain functionalities that is available, and when a company with expertise on that tries to build a particular forwarding and fast path processing software, the time to develop is lesser. The quality of the solution is better, so less incidents in the field and less, you can say, customer escalations. The second thing is that there is a constant upgrade and support that is available from these established players like Intel. They continuously innovate and come up with things like QAT and other solution accelerators, which can help achieve advanced functionalities like encryption, decryption to be implemented in rapid way. Similarly, there are other advanced components, what we're showcasing in our case study also, where if you want to deploy new services like, say, analytics or machine learning, then you can quickly integrate an FPGA module with the CPU and offload these services. Again, with the available IPs that Altera has, which is now an Intel company, the time to develop the solution is much lesser. So there are quite a significant, you can say, gains achieved, not only in terms of the savings in terms of capex and opex, but being able to kind of build and deploy your services faster, and thus starting your revenue streams faster.
Thank you. That's all the questions that we have today. I would like to thank Dhamaraj, Hernandu, and Arsalan for taking the time and providing this informative presentation. And I would like to thank our audience for joining us today. I hope everybody has a good day. Thank you.